Good morning, students. So in the last class we discussed about some reactions of alcohols in that mechanism of hydration of ethene to ethanol and dehydration of ethanol to ethene. Both are acid catalyzed, and the reduction of aldehydes and ketones to form alcohols. Okay. So today we are continuing with the same. So the next one reaction is fourth one, that is esterification. Esterification reaction. So that we already studied when doing that earlier ketones chapters. Okay, before starting that repetition. Esterification means formation of esters. So by which? By using the reagent alcohols. Of course, alcohol is esterification reaction. How? So initially I write up. So listen, students. Along with alcohol, you may consider carboxylic acid, or acid chloride, or acid anhydride. You may consider all these as a reagent. Carboxylic acid, acid chloride, and acid anhydride. So if the alcohol is going to react with all these species, they form esters. Understood? So here, what happens? Listen. So in the esterification reaction, we need to use concentrated H2SO4, small amount as a reagent. Why? So listen. ROH is there. I'll take carboxylic acid as the reagent here. So I'll write it as RC double bond OH. So students, this is carboxylic acid, this is alcohol. I just replace these bonds here. Okay? And this replace this OH here, this alcohol. Both are carboxylic acid and alcohol. So here what happens? In presence of H2SO4, which type of H2SO4 it is? Concentrated H2SO4. So the concentrated H2SO4 is a dehydrating agent. Understood? So it removes either, okay, H2O is removed from this. Okay, so then the product form is R O C double bond O R. So you may write it as this is the reverse R C O O R. It may be also written as R C double bond O R. Both are same. This is what? Ester. This one is alcohol. This is carboxylic acid. How do you write the explanation? When alcohols treated with, or instead of treated with, consider reacts with. Reacts with carboxylic acid. Carboxylic acid in presence of concentrated H2SO4. In presence of concentrated H2SO4 forms ester. Okay? This process is called as esterification. This process is called as esterification. Understand? So what here? When alcohols reacts with carboxylic acid in presence of concentrated H2SO4. That concentrated H2SO4 is what? It is a dehydrating agent. Dehydrate, remove water molecule. So then it forms ester. This process is called as esterification. So if we consider the example here, I just replace this R group here, CH3 OH. What it is? Methanol reacts with CH3. What? Ethanoic acid forms or reacts in presence of concentrated H2SO4. Okay, what is the product formed here? Again, water molecules. So that is CH3, C double O, C double bond O, CH3. Okay, so here plus H2. So students, this group, listen here, CH3COOH acid, ethanoic acid. If we remove this ethanoate, when we remove H, this is called acetate, okay, ethanoate. So to this ethanoate ion, this methyl is substituted. Okay, then we write ethanoate. Okay, so can you write the explanation here? Listen, when in the place of alcohol, just write methanol. When methanol reacts with carboxylic acid, which is the carboxylic acid here? Ethanoic acid. Ethanoic acid. When methanol reacts with ethanoic acid in presence of concentrated H2SO4. Okay, forms or give this one ester. What it is? Methyl ethanoate. Okay, methyl ethanoate. So this is the answer. With an example, esterification with an example. When we use carboxylic acid as a reagent. So here another two are there, acid chloride and acid amide. Let's see what happened. Remember, in this, the reagent or the product obtained from here is what? H2O. Remember that. Next. Next one, consider this acid chloride, especially acid chloride. Okay, so consider ROH here to this R C double one O Cl is it. I hope you easily understood. Okay, so this is what? Alcohol. This is acid chloride. Okay, this is acid chloride. So students here, you take instead of acid, you take acid chloride. Acid means if it is CH3 group. So yes students, you can easily say which is the byproduct formed here. So here HCl is going to remove. Okay, so that the product formed here is R O R. So this is ester. The reagent here is HCl. Understood? Okay. So here can you write 1 alcohol is treated with acid chloride forms ester. Okay, this is the explanation. So if you take the example here, so I'll take methyl only. That is a simple example because our group can be replaced by anything. You don't bother about that. So this is methanol. This is acyl chloride. So here, what is the reagent formed here? Of course, HCl is removed. Then it is CHO, C double bond CH3. So that is methyl ethanoate ester and the liberation of HCl. So can you write the explanation? When this methanol is treated with what? Acyl chloride. Treated with acyl chloride. Forms what? Yes, the ester name is methyl ethanoate. Methyl ethanoate. Understood? So similarly, if you take this one as the example, and directly write the general reaction, that is the commercial necessary. ROH plus R C double bond O C double bond O R. So students here, how the bond break will take place. Listen, either this so here it is C. This one is R C double bond O. Here it is bonded with this means OH plus this one is R. This is O C double bond O. So this one is ester. This one is carboxylic acid. So means no matter whether it is acid chloride or acid anhydride, the reagent found is they undergoes what? Esterification reaction. This is acid anhydride. Of course, this one is alcohol. Okay, so students, when there has as esterification reaction, the best thing is esterification reaction by using this carboxylic acid. So how can you confirm? Of course, in the reaction we wrote, this is how the esterification reaction confirm. So if we conduct this laboratory, okay, so in the laboratory if we did this reaction esterification, how can we came to know what is its confirmatory test means? When an acid, when an alcohol is there, to that acid is added and that H2SO4 is added and it is shaken. So then we observe, when we smell that, when we inhale that, then we feel a fruity odor. We smell, we sense a fruity odor. So that fruity odor is the characteristic odor of this ester. That fruity, if fruity odor forms, ester is formed. If there is no fruity odor, there is no ester. Okay, that is the confirmatory test for esterification. If the fruity odor, the characteristic odor of the ester it forms, then in the laboratory we can confirm. Of course, the esterification reaction takes place. If not, there is no esterification reaction. So this is our good. So in the lab, students say, so this is to distinguish between the functional group, to identify the carboxylic group as well as alcoholic group. This definition is one of the best reaction to identify functional groups. One is alcohol, another one is carboxylic acid. Next. So another one is Lucas test. Understood? Another one is Lucas test. So this is the distinguished test between primary, secondary and tertiary alcohol. Okay? So students, how the test is this? Listen. Alcohol is only test. Observation. Inference. Okay? So alcohols plus Lucas reagent. Okay? Later I will say what is Lucas reagent. So if immediate turbidity forms, then it is a tertiary alcohol. So alcohol, when a Lucas reagent is added to the alcohol, if we observe immediate turbidity, then it is tertiary alcohol. Next, so turbidity after 5 to 10 minutes, that is secondary alcohol. Okay, next. No turbidity after 10 minutes, that is primary alcohol. Okay, so if alcohol is there, we need to check whether it is primary, secondary, tertiary. What we need to do? Just we need to have a Lucas reagent. So students, what is Lucas reagent? It is important for 1 mark. So listen, Lucas reagent means it is anhydrous zinc chloride in concentrated HCl. Important for 1 mark. In the laboratory examination, also in the Viva, tell us what is Lucas reagent. Anhydrous zinc chloride in concentrated HCl. So if alcohol is there, to that we are adding zinc chloride in concentrated HCl. If we get immediate turbidity, that is tertiary alcohol. Turbidity after 5 minutes, secondary. There is no turbidity after 10 minutes, that is primary. Understood? So this is our about reactions of alcohols. So the next is phenols. Next is reaction of phenols. The first one is preparation from diazonium salts. From diazonium salt. So just to take the example here, diazonium salt means this benzene with this group. This one is plus, this is minus. This is called as diazonium. chloride. Diammonium chloride. So what we need here? OH. Because we need to prepare phenol. We are studying alcohols and phenols. So that's why hydration or hydrolysis takes place. Okay? So hydration or hydrolysis takes place as I told you. Okay? So this we have called warm air. Then of course students, means one is H plus, another is OH minus. OH is attached to HCl is liberated. At the same time, N2 is also liberated. This is a preparation of phenol from diazonium salts. Means the diazonium salts are treated with water or warmed in presence of water. They form phenol. Understood? So next one is only two important major reactions are there for this preparation of phenol. Second one is from cumene. From cumene. So what is the cumene structure of cumene? Is isopropyl benzene. Benzene is called as cumene. So propyl, and write CH3, CH2, CH3. Iso means the secondary carbon atom. So to this, benzene is attached. This is called as cumene. Isopropyl benzene. Okay, so this cumene undergoes oxidation. Cumene undergoes oxidation. Okay, so here oxidizing reagent used here is what? Lead, hydrogen, H2O. H2O, it is oxidizing reagent, O2 is added here. Understand? So then what happens? Listen here. Clearly listen students. This is the benzene ring. Here it is C, H, CH3, CH3 is there. So then what happens? This oxygen is inserted in between the carbon. H2O2 is inserted here and H2O is liberated. So then what happens? I will just replace this. Remember, this is CH and then CH3. So this H, this oxygen is inserted here. Okay, so then what happens here? What we need? OH we need. Then bond will break here. So then benzene ring with OH plus CH3, C double bond CH3. This is acid of propanol. This is phenol. So this is a preparation of phenol from cumene. So this one is benzene, cumene, hydro peroxide. Okay, this is very important for very important. Understand? Preparation of phenol from cumene. Understand students? So CH3, CH, CH3, cumene is there. So oxidation takes place. Then therefore cumene peroxide, because OH is in, oxygen is inserted here. Later with acid. Okay. Next. Students, next one is the chemical properties. Okay. So initially, before going to explain the chemical property of phenol, I'll say the resonance structure and explain. So here, benzene ring with the phenol, we have lone pair electron. If the lone pair electrons are there on the oxygen atom, they involved in the resonance, these ships here. Means benzene ring, here double bond OH, only one pair of electron. So here these electron shifts here means that is minus in charge. Okay, so these involved in the resonance means, of course I didn't write, you just remember. So if the resonance takes place, here also we will get minus charge, here also we will get minus charge. Means at argon para position we have more electron density. Means these alcohols gives a more alpha and para substituted product rather than metal. Understood? So whatever the chemical reaction they show, they exhibit, they form alpha and para product. Okay, so this is the lesson. I need not to write it again because I already explained this resonance in allo alternates and allo arrays. Allo arrays, I explained. Same happen here also. In Cl atom also lone pair electrons are there, they involved in the resonance. In OH oxygen also lone pair electrons are there, they involved in the resonance. Okay, so the next one is when they form argon para product, of course fluorination follows same, bromination follows same, nitration follows same, sulfonation, Friedel-Crafts acylation, Friedel-Crafts alkylation, everything follows same. But there is a difference in nitration and bromination. What is the difference? Yes. So listen, if the nitration takes place in presence of dilute HNO3 instead of concentrated HNO3, if the chemical reaction, that is nitration of phenol, takes place in presence of dilute HNO3, then consider phenol here plus dilute HNO3, or instead of writing here, okay, dilute HNO3 as the reagent. So students, here what you will get, one is argon-nitro, another one is para, means argo, nitro, phenol. This one is para, nitro, phenol. Understood? So this one is of course phenol. Well, when it is dilute HNO3. So another one case is there. Second one, when it is concentrated HNO3. Okay, so if phenol is treated with concentrated HNO3, what is the product? So this is the phenol. This one is concentrated HNO3. Understood? So here it is formed. Which type of product means tri-substituted product. Here it is OH, here also NO2, here NO2. So with respect to this, it is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So this is what? 2, 4, 6 trinitrophenol. So students, this is also called as, it is very important, this is called as picric acid. Okay, so this is 2, 4, 6 trinitrophenol is called as picric acid. Understood? So this one is phenol. Same thing happening in bromination. How? Listen. So initially, so bromine in carbon disulfide. Understood? Bromine in carbon disulfide. Just consider OH. Here Br2 is there. Okay. So here CS2 is the reagent or sorry. Solvent used here is what? Carbon disulfide. Then the product formed is one is orthobromophenol, another one is parabromophenol. Okay, this one is orthobromophenol. This one is parabromophenol. So this is phenol. Understood? So instead of that, if we use bromine water. So here it is. This benzene ring. Bromine water. So then the form. Here you have to take 2 Br2, here you have to take 3 Br2 because here 2 HBr will come, so here 3 HBr will come. So OH, here it is Br, here it is Br, here it is Bu. Means tri-substituted bromophenol will form. So here it is 2, 4, 6 tribromo-phenol. Understand? Okay. So this is all about chemical properties of phenol. Another one is there. It is always reaction and remote temper. Those are new reactions. Understand? So this is only the difference. If we use concentrated HMO3, then 2, 4, 6 trinitrophenol is the product. If we use bromine water, here the solvents are different, then 2, 4, 6 tribromo-phenol. Here it is trinitrophenol. These two are very important for totals. Then as like this only. So what is explain nitration of phenol in presence of dilute HMO3? Explain bromination of phenol or then as halogenation of phenol in presence of carbon disulfide. Like that only there is. Understood? So students, the next one is okay. So the next one is Pole-based reaction. Okay. Next one is Pole-based reaction. So here what happens is phenol, conversion of phenol to salicylic acid. Conversion of phenol to salicylic acid. Understand? So here what happens? Listen. Initially, phenol is the reagent. Okay? So this phenol is treated with or fused with NaOH. Phenol is fused with NaOH. So then they form sodium phenoxide. Sodium phenoxide. So later this sodium phenoxide is treated with carbon dioxide followed by hydrolysis. The sodium phenoxide is treated with what? Carbon dioxide followed by hydrolysis. So, okay, followed by acidification you take. Instead of hydrolysis you take acidification, H plus content. Okay, so they form, of course, as this is a phenol group, we know that RONA. So this is CO2. So students, listen, when here CO2 is added, this is steps I am writing here. When first step when it is reacted to, the COOH will form. When it is acidified, then this Na is replaced by H. Are you getting? That's why I wrote like this. Don't think where did this Na went. So these steps initially listen. So this is ONA means. So first this is treated with CO2 means it forms ONA COOH. Then it is treated by any acid. So then what it forms? Of course COOH is already there. Here it is OH plus NaCl. So that is what I wrote here. CO2 followed by hydrolysis. Okay? How do you write? Explanation. Sodium phenoxide ion is formed when phenol is fused with NaOH. Okay? The resulting product means sodium phenoxide is treated with carbon dioxide followed by hydrolysis followed by acidification gives salicylic acid. So students remember, this is phenol, this is sodium phenoxide, this one is salicylic acid. Salicylic acid is the common name. So if I write the IUPAC name, this is the COH group, most clear group. The first and the second position is, that is 2-hydroxy benzoic acid. So this is also called as salicylic acid. You may write it. In the place of salicylic acid, you may write the 2-hydroxy benzoic acid. This is cold-base reaction. It is important for 2 marks as it is a neighbor reaction. Understood? Very important for 2 marks. But it is, so remember, only this step is the, what is that? cold-based reaction. Here what happens? Phenol is treated with NaOH first. We need to protect this OH group. Why? Because hydrogen is most reactive. Understood? They are more affinity towards the CO2. That's why we need to protect this OH group. And this phenoxide ion, they involve in resonance. Now it becomes stable. It is protected. And later, CO2 followed by acidification gives the reaction. Okay? So in the tomorrow's class, we will discuss with the further reaction. Thank you.